Hello, everyone. Thank you so much for taking time to attend our session here. You want to introduce yourself and then I can go?
Yeah, sure. Hello, everyone. My name is Parminder Bagri. I'm with the state of California, chief of the enterprise infrastructure team.
Hi, everyone. I'm Devin Dharm. Some of you may know this. I specialize in aging my own tequilas. I also have expertise in analytics and cognitive technologies, and over the last 20 plus years, been delivering various kind of analytics solutions from descriptive to prescriptive technologies to various state and government clients. Today, we'll be talking about one of our recent success stories here, where we completely transformed the analytics infrastructure at CalHEERS and how we have taken it to the next level, elevated the game, if you will, in terms of analytics. So in terms of the agenda, we will give you a brief overview of what CalHEERS is, the magnitude of CalHEERS and the kind of business we are in. We'll talk a little bit about the challenges that we faced when we started with the pandemic as it hit the market. It sort of exposed the vulnerabilities of our systems that we had never imagined or planned for such unprecedented changes in data volumes and other things. We'll talk a little bit about that, then go into what were the objectives of our tech refresh and walk you through the journey we took to arrive at that stage where we are today. Just a couple of weeks back, we went live, and we are proudly now in production with this improved infrastructure using Databricks. With that, without further ado, if you want to go into
Sure.
and give us a brief about CalHEERS.
Yeah. So just a brief introduction on the CalHEERS. So the Affordable Care Act of 2010 required the states to have the state-based exchange, the marketplace where people can buy affordable health care or use the federally set up the exchange. So the CalHEERS came into existence. So where the CalHEERS actually stands for California Healthcare Eligibility Retention System. So where the people in California, they can come and do the research and compare and check the eligibility, eventually buy affordable health care. And so California, this exchange provides at least 1 out of 4 Californian a platform where they can shop and get access to affordable health care. And the data warehouse team plays a very critical role in that, which run the analytics on it, and then provide the very key data elements, the reports to the executives, to the decision maker, for the future policies, and how to provide more affordable healthcare plan to the consumers of the people of California. So just to give you the overview of the scale of the CalHEERS, we have around 6 or 8 different subject areas that we run in a data warehouse. And we have 250 jobs to process those 6 subject areas, which runs every night. And the size of the database is around 48 terabytes. But the source system from where we ingest the data is 3 different data sources. So those are around 150 terabytes of data that we actually ingest. So far, we have accumulated 9 years of history into the data warehouse. So this whole project is possible with the collaboration of Cover California, the Department of, the Office of System Integration, OSI, Deloitte, Department of Healthcare Services, and the Databricks. So the mission just for the data analytics team that we have is to provide the decision to design, implement, and evaluate the Cover California portal that we have to inform, have the timely, rigorous evidence about customers' experience. So then the proper decisions can be made, or the future offering can be made to the people of Cover California. So these are the technical challenges that we faced in our legacy system. So with the pandemic rolling in 2 years ago, the CalHEERS was already struggling with its ETLs, with its jobs. So we had delay, the jobs were completing in the middle of the day, and we were not able to deliver the key reports to our executives so that they can make the decisions. And also with the pandemic hit, the data increased 10 times more than what we were expecting it. Because a lot of people were relying on this system to get access to the healthcare. So the data was coming in different sources. We had 3 different sources coming, and then there was some data which was like a very structured data, and then the challenge was there where the data was semi-structured data. Since the jobs were completing late, and like the late delivery was cutting down the analysis time when the jobs were finishing. And then late availability of that reports to the executives was kind of like lowering the confidence in the quality of that data. And then our analytics teams, especially the data scientists, the business users, they lack those tools so they can run it on this legacy system to produce the data or to look at the data in the different dimensions. So here you can see the volume of the data that we were saving. So the CalHEERS exchange, like the way we have it, we don't have this year-round, the similar flow of data. Always we get like 3 different flavors. One is a typical load that we get throughout the year. Then we have the open enrollment, which starts in the end of the year for October, November. It goes for 3 months. That doubles the volume that we receive it. And then on top of that, we have the back-end jobs, which is running to process millions of consumers for redetermination of their eligibility. And those rules are very complex rules to check their financial eligibility, their dependency, the household size, and we have to call different the interface partners. So all that generates like billions of records. And those records sit like in multiple tables, and the data warehouse has to ingest all of that data overnight and produce those reports in the morning. And then that's where it was making a challenge. The executives are not having access to the dashboard. And the data was getting delivered late. And because of that, the confidence was very low on that quality of that data. So these were some business driver, which it drove us to think about the new technologies that we need to have it to solve all these technical problems, the business problems. Especially during the pandemic, the consumer behavior change, their profiling change, and the data change. And then we had this, like a public health emergency, which was put in place by the Biden administration, where we were exempting a lot of consumers, a lot of Californians, so they don't have to go through those rigorous redetermination. We were just about like giving them the healthcare, affordable healthcare, so that they can protect their families. Now, with that coming to end, public health emergency, like it's been recently announced, that means all the people had to rerun for the redetermination, that we have to check whether they're still eligible with the current income or not. So that triggers millions of notice goes out to the different households. So that requires them to take an action, whether how to stay in this marketplace so that they have uninterrupted access to healthcare coverage for their families. So that's when the Deloitte, the CalHEERS, we collaborated with our sponsors, Cover California, to come up with a new solution. And they contributed heavily. We had different teams from Cover California. We had the business users. We had the data scientists. We had the technical people who came in, helped us, lock down the requirements and come up with the, a new solution that we had to come up so that we don't face all these challenges that we've been facing in the legacy system. So we put up all these 4 objectives to solve this so that we have the guardrails to deliver the results. The first one was obviously the first challenge that we were already facing, the performance. So we said that the solution that we needed, it should be very optimized, the performance, and we need to have access to those reports, especially the dashboards for the executives, so that it's available in the morning, first thing in the morning when they start the day. And then also, the improve at the same time, not spend too much, but have, a cost efficiencies also delivered to us from the legacy system, so that we don't invest too much on the infrastructure, and then also the licensing costs that we've been paying to our legacy system. And also, we needed, since our data volume is in such a way, the business is such a way that it's not consistent throughout the year, we get the peaks and the valleys. So that's where we needed a solution which can scale for the demand, and then we don't need it, we can just scale it down to save the cost and to save the infrastructure. Then also, we needed the future innovation, so that we have the ground, we have the environment available where we can implement the new innovations and leverage those capabilities for our business users and the data analytics team. I'll hand it over to Devin here to go over how we went through this journey to deliver that quality product.
Thank you, Parminder. So in addition to the great technology objectives that Parminder just talked about, we also wanted to enable ability to support advanced analytics use cases, such as the ones that you see on the screen right now. If you take a step back for a moment and think about the mission of Covered California, then the mission is essentially to provide affordable healthcare or make healthcare more affordable so that more families can actually get insurance and achieve, get the benefit that they deserve, that they need. In order to be able to do that, we needed an ability where we can do deeper level of analytics. For example, eligibility analytics that you see on the screen. The business users needed an ability to analyze exactly at the point where the consumer chose the plan, what was the parameters that drove that selection. We needed an ability to do enrollment level analytics, so to be able to account precisely the credits and the premiums that they are getting. Parminder earlier mentioned about the public health emergency. It's a phenomenal event that is happening right now as we speak here. A year ago, Congress passed the American Rescue Act, for those of you who have been following. With that act, so many more people were able to get enrolled. That's why last year saw a record number of enrollments, because the service better credits were provided and the premiums dropped down drastically, which allowed more people to actually afford health insurance. Fast forward to today, we are seeing a potential situation where that emergency is going to be called off and those benefits may be taken off, which implies that the premiums are likely to go up. What does that mean? So it means that there may be several families who have to think that, can I still afford insurance? It means that there are going to be significant amount of transitions in and out of the plans that we see in Covered California. Transition analytics is going to pave the way to allow the business users to really analyze the situation so that they can maximize the benefits. Most people can get insurance. Last but not the least example that I have here, plan choice analytics. Plan choice analytics is all about, there is a lot of evidence and research that has gone into this, that selecting a plan is not the most easiest task for users. It is fairly hard to select the right plans, to make the right choices. Most choices get made based on what is the deductible I'm paying, which is not necessarily the most correct way to choose a plan. Now, the plan choice analytics, what is it's going to do for Covered California is it's going to allow the business users to analyze what dimensions are actually affecting, influencing that decision making. Not every user also what we call it as numeracy, ability to understand numbers and play with numbers. Not everybody is conversant with numbers, as each other. So they don't end up making the right choices. So how can we really elevate the experience of that consumer by providing them something that nudges them towards making the better choices in terms of the plans? So that's an important objective that we want to. Now, these are just examples. We have worked with the likes of Kevin and his deputies with the policy team to build a 3-year roadmap of several initiatives such as these, which we would be able to actually embark on those with the kind of infrastructure we have been able to set using Databricks. With that, did it work? OK. So now let me describe to you how we got here from the state that Parminder described when the pandemic hit and life was all chaotic. to where we are today. So we started somewhere in Q3 of 2020, where we did an assessment of the existing data warehouse environment across 10 different dimensions. We assessed the data model, we assessed the data integration capabilities, we assessed the security of the environment, we looked at the self-service capabilities, we looked at the technology stack, the ability to other architecture abilities such as scalability and other aspects, several different dimensions, and then came out with 48 different findings. I won't go into each of those findings, but what it prompted was that we needed a better infrastructure that can actually provide users with what they need. In the Q4 of 2020, we interviewed several stakeholders. There's a really funny statement made by one of the users. We have a subject area called
Eligibility?
No, the other subject area. We have one, submitted individual is a very interesting subject area. Over time, it had become so complex and so difficult to get any meaningful data out of that subject area that the users told me that we have divorced with submitted individual, that nobody's actually accessing that information and able to get anything meaningful out of it. So those are kind of the emotions that we dealt with. We sat with them, understood their use cases, how they're trying to use data, realized that they're spending significant amount of time just getting to the data as opposed to actually using that data meaningfully. We use that to really define the blueprint of what should that future look like. We looked at various architectures. The paradigm that came forward was a modern open data lake architecture where the state has control of the data and where you can bring your tools as tools continue to evolve in the market. You should be able to bring those tools, but still the state should own the data. That's the kind of paradigm we finalized. And then did a gap analysis. What is the finite set of steps you need to take to go from where you are today to realize that vision that will allow us to do all of those strategic use cases that we were talking about. And finalize the tool selections, tools that we wanted. Databricks clearly came out as a winner in the data processing space. Q1, Q2 21, and then from then on, we have been working towards implementing, and really proud and happy to say that we went live about a week and a half ago to realize all of these visions and dreams. So kudos to so many people who helped us in that journey. The interesting thing about our journey is that this was not just a technology upgrade. This was not a lift and shift operation. This was a fairly dramatic redesign of the entire state-based data model, taking into consideration all of the key use cases that you would want to be able to deliver to your business users. Obviously, it's going to take us a few more years to actually realize all those use cases, but now we have that infrastructure. And we really simplified the data model so that business users can actually directly work with the data themselves without having to constantly rely on IT staff for every single data need that they have. So that was one of the key aspects of this. And again, here is the solution. So this is what we propose. I've tried to put together a simplified, abstracted view just to keep the conversation simple. But as you can see, we have sources on the left, ingestion using Databricks. Databricks brings some really phenomenal features, such as schema evolution, which basically means that as source system continues to evolve, add more columns, we don't need to reopen more CRs to do more work to start, to update the same ETL jobs. Those new columns will automatically flow into our data lake. So we are doing schema on read. So we are not imposing a design on our ETL when the data is being read, which is an amazing paradigm that helps. I've always been a proponent of a pattern called as persistent staging layer pattern, where I like to keep every single version of data that I have ever received from the source system because we trust no one. I need to be able to reproduce exactly what happened on any particular day. And if we realize that there is a data issue that is discovered late in the game, say a month down the line, I have a complete ability to go back in point in time and restart my ETLs from that point onwards. And Databricks really makes it simpler. In fact, it takes it one notch higher. The tables have an easy version number implemented, where I can simply choose a version number and just go back to a point in time and restart all of my work. Amazing feature. So there are several such small features that really make the job of a data engineer simpler. You do need a good architect to implement all of these. We have implemented a very powerful audit, balance, and control layer. Basically, audit means that every single movement of data that ever happened in our lake is tracked. We can precisely pinpoint who sent what data when at any point in time. Balance basically means that we treat our ETL like a balance sheet. If you withdraw $100 from here, you deposit $100 over here. We do that check at the end of every ETL run in an automated fashion. So we know precisely, we sleep well in the morning, we don't check our emails, did it work or did not? So all of that is managed by the process. I used to wake up in 2 years ago. That was a reference. But anyway, so and control is another important element that we improved in this architecture, where we now have the ability to run this ETL process as many times as we want in the day. We can run micro batches if it comes to that. We can really allow the data to trickle sync into our data lake so that we can make data and insights available sooner if needed, which is a remarkable improvement over what we had. So the central part of the architecture, you'll see that we have the intake layer where we store raw information, and the curated layer where we cleanse the data. We take it through data quality. We have a strong data quality framework. Maybe in a different session I can go deep into that. But it allows us to understand the data quality thresholds. We have dashboards that tell us the deviation in terms of the quality as it compares with the data in the source. So we know precisely the health of our data in the warehouse. From that layer, we then push the data to the provisioning layer for consumption by the various users. As you can see in this architecture, it is a fully ready for machine learning and predictive analytics. Our users can have direct access not only to the provisioned data set, which are structured or optimized for read, but they also have access to raw data sets, which means they can do deeper level of analytics to understand, for example, consumer behavior. What drives consumer behavior is a very complex question to be answered in state-based health exchanges, because that's what leads to decisions, and one of the most complex questions to be answered. But that's what this architecture does. Let me spend a little bit of time. This soothing light is giving me a warning that I need to speed up. There are 4 impacts that I want to talk about with respect to the objectives that Parminder talked about. First objective was to optimize performance. We blew that out of the park. We are now able to handle extremely high volumes of data with this new architecture. We get our performance. I'll show you a slide, a proof point of the actual data. We are at least twice as fast, which means that now we have created room for doing more stuff. The seasonal variability that Parminder talked about, it's a reality of state-based health exchanges. There are open enrollment period where suddenly people start coming to the website, and then there is this passive renewal period when millions of users are going to be passed through a batch process where everybody is going to get redetermined. So suddenly there is unreasonable spikes, and you don't want the infrastructure to be sized for that 10x capacity all the time. So all of that variability can be handled seamlessly in this architecture. Here's the proof point where you can see the line above depicts the time we have taken in the existing architecture. The line below is what's happening in the new architecture for 3 different volumes: the typical volume, the surge volume, and the stress volume. You can see that in all 3 cases, we're at about half the time we are able to run that. It actually means a lot, because you have an ETL window for you to finish your job in the night to get executives what they need in the morning. So now we can actually do more in that window. It affords us an ability to, we in fact added 1 extra subject area the eligibility analytics that I described earlier, that is actually possible and also accommodated within this timeline, which is great. The second impact I want to talk about is operational efficiencies and lowering costs. That was the second objective. With Databricks, maintenance becomes significantly simpler. It's a SaaS solution. Patches, all of those are managed automatically by Databricks. It's a pay-as-you-go sort of model where you can enter into buy a capacity for some amount of time, but then as you need additional capacity, you can increase the capacity. Then operational costs, just to give you a sense of the improvement that we have achieved, our original infrastructure resided on a monster machine, which I used to call relational databases on steroids, which had 576 CPUs and 4 terabytes of memory to just process this on a nightly basis, and still we were struggling to deliver the data at 8 a.m. in the morning. So from that environment, few hundreds of licenses, core-based licenses, if you know what I mean, to a state where now we are completely serverless. We only invoke the servers when the jobs are running, only for that finite amount of time. So that's led to improving the operational costs. Okay. Then, third objective was elastic scalability. Again, I won't belabor this. We talked about this. The variability can easily be handled by enabling auto-scaling. One public service pro tip, don't go wild on configuring that scaling. Don't configure 5 to 40 nodes as you're scaling because it will scale very easily. So be watchful on that. High availability is an amazing setup. We have created a setup which allows us, in case the Databricks goes down, immediately the failover will reinstate all of the Databricks installation and the jobs can continue. If the entire region were to go down, we have a CloudFormation template stored outside the region, which will stand up the same installation in a completely different region, and still the business will continue. So that's the kind of high availability solution we have been able to set up. Last but not the least, I'm still doing well on time, I think. Last is to foster innovation. That objective is probably the most impactful objective because, as I mentioned, this roadmap of initiatives, now we will be able to embark on that journey. It's the environment created using Databricks is a completely unified environment, which allows all users, from data analysts to data scientists, and business executives, if needed, to access the same single pane of single copy of data, if you will, but use different set of compute resources. And these people can also work in the same collaborative notebook, as they're called. And these notebooks are very powerful constructs if you have worked in that paradigm, where they can interact with the data, they can get the result set, they can save the result sets. All of that whole progression of thoughts of how you got to an answer to try and do whatever diagnosis you were up to can be recorded in that notebook. And people can collaborate and comment and work together on that notebook, which is a phenomenal paradigm. As I mentioned, we did a dramatic re-engineering of the model, where we ended up simplifying that data model to an extent that business users can actually do self-service analytics. And because we're able to spawn separate clusters for these ad hoc users and separate clusters for data scientists who want to crunch, write some crazy ML code, crunching extreme high numbers without impacting those other users, we are able to do that. And that's how we have achieved our self-service analytics. So that was the fourth objective. With all of these, again, we have been highly successful in delivering the vision. At least that's what we feel like. We'll hear from Parminder whether we met that. I'll hand this back to Parminder to talk about how we delivered for the CalHEERS, or the value we delivered through this process.
Thank you. No, thank you, Devin. This is really great. I just want to summarize here, right? Like the cost saving, the high performance. So the cost saving, as Devin mentioned, right? So it's just twofold. That this is like a one piece in the whole our tech modernization journey, where the data warehouse was like a big piece out of that, right? Where we were using a lot of infrastructure, and especially the licensing constraint that we had with the legacy system. So now we are out of that, and then we can use this least expensive model to serve our need, and also deliver high performance, right? So then we are performing and delivering on time the reports in the morning to the executives. So just to give you the perspective, this 9 years of data, we did not just migrate as it is, all the summary. We actually recollected the data from the source systems and processed that data through this new system within a month, right?
Yep.
So the 9 years of data we processed within a month, and that gives you the sense of the speed and the performance that it provided, where we were struggling to process the last 24 hours data within 8 hours, so that it can be delivered to the executives the next day morning, so for their executive briefings. And then also, it gives the on-demand scalability. So it's not that we didn't have the scalability in the legacy system. It's just that we were on the cloud, but the licensing constraints were not allowing us to scale it. Also, it was not automatic scaling. It was more of a manual. You had to work with your existing vendor to get the licensing, and then spin up the machines and then scale it. But then what after that? Because the licensing model, the way it was, then you buy it locked in for the whole year, not just for that duration that when you need it during the passive renewal or the open enrollment. So improved uptime. We already spoke we had the DR solution in place, but it was manual. So if things failed, so we had to actually manually fail over and then restart the jobs from the beginning, not from where it dropped, we can pick it up. Now it's all seamless. If one node goes down, it just picks up another node, and the load continues, and still deliver on time in the morning. And the innovation, so this just creates the room at the ground for the future innovation. Also now, as Devin mentioned, so we have different users. We have the data scientists, we have the business users, we have the technical users. So earlier we had that continuous, the computation. Okay, you are taking my system down. Okay, you cannot do this. Now the way that we have implemented the solution is the data scientists and the business user, they have the view to the same data, but their different compute is assigned for them to do their job. So they can better analyze the data from their perspective and see the data 360 view, and then provide some valuable input to our leadership. With that, we conclude our session, and thank you very much for coming. We can take your questions.
Thank you.
Yeah, thank you. Good presentation. Want to understand, you have Databricks, and then you have Snowflake. Mm-hmm. Do we really need Snowflake if Delta Lake can support the objective? And why did you choose Snowflake?
Yeah, so when we, that's a great question, and I think that I was expecting that question. So I believe I'm well prepared to answer that question, but we'll see. So at the time when we decided on this architecture, it was 2 years ago, and the Delta Lake House concepts were still evolving, and we didn't have proof points to show that this architecture can actually work. And again, don't want to extend too much into the specific tool features, but I can go into more depth offline. But for what our users were trying to do, the tools that we selected seemed to be the most appropriate choice at that point in time. So that's what led to this architecture, and it is working great.
Can I have another question, since I have the mic?
Sure.
What are the analytical tools that you use? And I also saw the curation layer. What are the tools that you use to curate the data? So
the curation is also done. For analytical tools, we basically use Tableau for dashboarding and reporting. And we use PySpark for all our ETL. We use Python and Jupyter notebooks to access to the users to allow them to do collaborative analysis. Those are the tools essentially that we are using. The curation we are doing curation as a part of the ETL process itself. So our audit balance and control process actually allows us to manage the quality thresholds and invoke the quality rules are invoked as a part of the ETL process itself. There is no manual curation.
Thank you. I have one question for State of California. So you guys mentioned you use Tableau as BI tool. So how do you, it's a per user cost model for buying Tableau. How do you scale or budget that in your, in the state budget for something like that to purchase that tool?
So, thank you. Great question. So I'll start and then
Sure.
Devin, you can jump in. So we estimated the usage from the current tool that we had it. So and we came up with the best model, right? That this serves the need for our business users right now, just to meet where we are. And then there are some opportunity where we scale up as we need more licenses or more users. That they need to use it. So that's how we are allowing it. And we are bringing our business users, so in the past, they had their own license. They were using their local versions. So now we integrated that to our servers. So there is this common platform for all the users to use it.
Yeah, and to add to what Pramila said, with Tableau, you can actually purchase different licensing models. You may be aware of that. Not every user is going to actually be one who creates the reports. So there we have a limited number of creator licenses, and then there is interactors, which actually gives you pretty much 90% of the ability to, in terms of being able to. That's why self-service analytics that I was talking about is an extremely powerful construct that has to be architected and designed really very well to minimize your licensing costs on the creators. So if you have done that right, then you publish the certified curated data sets to the Tableau server, then you can use those curated data sets and give access to the users with just interactor license, and they can do the drag and drop and do that. In addition to that, most users are just consumers of information. For them, you can actually buy significantly cheaper packs of 100 licenses, viewer licenses they're called. They're $12 a pop per month. So that's how you sort of try to manage the cost associated with Tableau.
All right, guys, thank you so much. There are a few more questions. If you can stay for a little bit longer at the end of the room and take those questions, that would be great. Thanks.
Absolutely.
Thank you
so much.
Thank you so much.